Hello there. Today we're going to be looking at the unit circle and tying it into a little bit of geometry. Here I'm using two interactive applications, one from mathsisfun.com and the second from Math Open Reference. Both of these sites have plenty of fantastic resources, and I will have those posted on my website in addition to this video. The goals of this video are to go over how we can find the exact values of some common angles in their trigonometric functions, and then how we can extend that to all real numbers and look at it on a grander scale. For starters, over here we have what is defined as a unit circle, a circle with radius 1, which you can see both in the x direction and the y direction. And then there are some common angles here. We have a 30, 45, and 60, which are common angles you might see in a geometry class when you're going over special right triangles. And the reason that is because of the relatively nice coordinate points they have and the patterns you might see in them. Because in right triangle trigonometry, the sine value is defined as the ratio of the opposite side length over the length of the hypotenuse, which we can see over here, 8.3 over 10.5, gives you a measure of 0.8. In other words, this side length is 80% of the length of this side length. So if we go to values that are nice on the unit circle, well, if we're talking about sine, it's just the opposite side length over the hypotenuse. And if the hypotenuse is only 1, really the sine value of an angle is its y value. As you can see here, the y value of 30 is 1/2, and up at the top we see that the sine of 30 is 0.5. Again, meaning that the short side length on this triangle is half the length of the hypotenuse, and that works for all cases. When we go over to 45 degrees and both of the side lengths are equal, we see that the coordinate point has the same values, square root 2 over 2, comma square root 2 over 2. Both the x and the y values are the same, just as the sine and the cosine values are equivalent. As we go and try to extend this into all real numbers, if we take our angles and we turn them into radians, now instead of just having from 0 to 360 degrees, we can essentially plug in any trigonometric number we want. If we want to look at 1, now we can say that the sine of 1 is 0.84. This one isn't a unit circle, so we actually see a value here that's not just a hypotenuse length of 1, but the trig values would be the same. We can see if we go here to sine of, we can get close to 1, and it is 0.848, just as this one is 0.84. So here, this one lets us look at extending this to any real number. Oh, we want to know what the sine of pi is? Almost. Then it's about 0. Or it is 0. There we go. 0. So in reality, we can now extend the domain of our sine and cosine functions to any real number, and its range is limited to -1 to 1. Or in other words, the side length of this triangle will never be longer than the length of its hypotenuse, which is crucial because the hypotenuse is opposite the biggest angle, should always have the longest value. In conclusion, we looked at looking at exact values on the unit circle. In other words, what is the exact value of sine of 45 degrees? In this case, it is square root 2 over 2, which approximates out to about 0.707. And then over here, we looked at extending the domains of these functions to any real number and seeing what we get. Thank you for listening and watching. I hope this was informative and helpful. Have a nice day.